Hi, welcome to week 4 of social network analysis. This week we'll be looking at community structure within the network. First, we'll explain why community structure is interesting. Mostly it has to do with, instead of one big hairball, you have different regions within the network that are interacting within that structure more than they are with the rest of the network. So that's going to give you some information about what is actually going on besides, oh my gosh, everything is connected. Next, we're going to look at different definitions. How exactly do you define that this set of nodes is a community as opposed to this other set of nodes maybe is not? And finally, we're going to look at, given a network, how can you detect the communities within it, and how can you evaluate how good that those extracted communities are according to some criterion. So first, why do we do it? And I'll go through 3 separate reasons. The first is, well, these reasons are kind of social network specific. So the first is you can discover communities of practice. If you have communication between individuals, discovering which groups of individuals tend to communicate more with each other can tell you what is the structure of collaboration. So in a study done at HP, what they did was they took all the email communication, organically found what are the communities, and then they compared it against the actual reporting structure. So here gray is email and black is the reporting structure. And they found that in the vast majority of cases, the different communities, the communities just corresponded to the actual reporting structure. So if people were within the same unit of the organization, they had similar tasks, similar goals, and they tended to collaborate with each other. Okay, fine. This is a validation, right? You only looked at email communication and you applied your community detection algorithm, and what was spat out was totally reasonable. You got the actual organization back, which is informative. You can imagine doing the same study in an environment where there is no formal organizational structure, but you still want to know how did the individuals organize together. And this could tell you. What was particularly interesting in this study was that there were a few communities that were detected which tended to cross different organizational units. And so when the authors of the study, Joshua Tyler and others, went and interviewed those individuals, what they found was that they had tasks which in fact bridged different parts of the organization. So for example, printers with new networking functionality. Well, you needed the printer hardware people and you needed the people who know about networking. And so in a way, the community detection was giving a more accurate picture of the current collaboration structure than kind of the formal organization, which may or may not have caught up later, for example, by doing a reorg. This next example is a very, very classic example of the Zachary Karate Club. This sociologist, Zachary, was studying the interactions within a university karate club. And he said, well, who do you talk to regularly? Who do you like? Blah, blah, blah. And he got this social network. Well, while he was studying that karate club, there was a little bit of infighting with individuals in the club, and the club split in 2. The question is, given who was talking to whom and who liked whom, could you have predicted which way the club was going to split? And if you can, this is kind of a test for whether your community finding algorithm is good or not. Then that's useful. Imagine if you can look at any social network and you can say, well, if things get tough, I think this subset is going to go. So that seems useful. This next example is taken from the book. It's actually kind of a Payek manual that teaches you a lot of social network analysis as well. It's called Exploratory Social Network Analysis with Payek. And in this particular data set, which I've now remapped with Gephi, you have workers at a sawmill, that is, they're processing wood. And there are different kinds. So here you have the management. You have English-speaking workers, they're marked with E, and then you have different roles. So the Ys work in the yard, the Ps are the planers, and the Ms are the millers. And what happened was that the management wanted to introduce a new plan. And they thought that everybody would be on board because it was supposed to be beneficial all around. What they found instead was that there was a lot of resistance from actually the Hispanic workers. They called in a sociologist who mapped who talked to whom frequently. And after mapping everything out, said, I think you should talk to Juan. The management talked to Juan, explained the plan. Juan said, I will talk to my friends. Next day, practically everyone was on board with the plan. So the quiz is, why did this happen? What is it about the structure of this network that would have told you that talking to Juan is the correct answer, the correct thing to do? In this final example of the usefulness of community finding in social networks, we'll look at opinion formation. So what I'd like you to do is to actually go to this link. Let's see if I can find it as well. Hopefully. Okay, so here you have two choices. You can either create a network that has community structure, and you can lay it out a little bit more so it's more clear, or you can turn community structure off. So I'm going to create an Erdos-Renyi graph instead, and then you can do something called update opinion. And what happens is that each node looks at two of its neighbors, and in this case it's changed its opinion, it's turned into a square. And what it does is if a majority of its neighbors have, say, the red opinion, it will switch to red if it isn't red already. If it's equal numbers of red versus blue, it'll just flip a coin and it may switch or it may not. So I'd like you to do this repeatedly for the Erdos-Renyi and the two communities and see in which case you can have divergent opinions persist in the network in the long run. That is, you do a lot of updates of the opinion, and sometimes, though not always, different parts of the network will maintain a different opinion. So let's try and go back to PowerPoint. Excellent. Okay, so this is your quiz question, which I'd like you to answer. So hopefully what you saw was that when you have two separate communities, because individuals can have more ties within the community than outside of the community, they can actually, they're seeing like-minded individuals and they can persist in their opinion even if, say, the rest of the network is thinking something else. They're just not evenly mixed enough such that they would be influenced and the opinion would propagate throughout the network. So in this final example, it's a high resolution map of science that the researchers did in a very clever way. They looked at access patterns in online repositories of scientific articles, for example, JSTOR, or actually scholarly articles. The JSTOR has a lot of humanities and social sciences, and natural sciences, it's mostly on the biology end of things. And what they did was they looked at, if you access an article in this area, what other areas are you likely to be exploring within the same browsing session? And if we look a little bit in greater detail, you can see things, for example, plant biology being closely tied to ecology and biodiversity and environmental science. And what's more, you can then collapse these different communities into metanodes and see how the metanodes are then themselves related to each other. So pretty neat applications of community finding. And in the next segment, we'll get to the more difficult work, although still fun, of trying to define what exactly are these communities. And then in the third segment, we'll look at how do you actually find them.